Okay, so in this lecture, we're going to introduce a new technique for finding the integral of rational functions. So recall that a rational function looks like n of x over h of x, right? So where n and h are polynomials. Okay, so if your function looks like this, there are a few ways that a few forms that it can take. Well, two. They can be improper and proper. So improper rational functions, the degree of the polynomial in the numerator is higher than the degree of the polynomial in the denominator. And in that case, you can use polynomial division, long division, to simplify and write it as a polynomial plus a proper rational function. And again, by proper, I mean that the degree of the polynomial in the denominator is greater than the degree of the polynomial in the numerator. So we've encountered integrating rational functions several times, and we've used several different techniques to deal with them. I think the most recent was the trig substitution, where we had rational functions with polynomials in the numerator, or no, denominator. But a lot of times sometimes you can do trig substitution for rational functions, but then it might be a lot of work, or it might not actually work to get it done, and you can get stuck. So the method of partial fractions takes care of this. And there is a bullet point list in your textbook, but as typical, I try to shy away from the tables and just think about what's going on. And the general idea is the important thing. And the idea is this. If you have a rational function that is in a proper form, so it's not an improper rational function, you can write that as a sum of, what's the best way to describe this? A sum of ratios where the denominators of the ratios are of the form px plus q, so like a linear term, or a quadratic term. So in a college algebra course, you will learn that you can always factor a polynomial into a bunch of linear and quadratic terms, where I think the terminology is that the quadratic terms are called irreducible. So once you factor that denominator, you can then write it as a sum where those factors appear in the denominators of that sum. Okay, so I think that's a vague way of explaining it. To be more specific, we need to reverse the process that we typically have done in the past in like a pre-cal or college algebra course. So typically, like you would encounter things like this on this side, and then you would go this way. Right? You would combine these by multiplying both sides by x plus 3, and so multiply this by x plus 3 over x plus 3, multiply this by x minus 2 over x minus 2, combine like terms, add them, and get to here. We're going to go the opposite way. We're going to start here in the combined form, and we're going to expand out. And the way that we can do this is by fully factoring the denominator into these linear and quadratic factors. Once you've done that, you set up, well, I'll illustrate it with this example, I suppose. So notice first that this denominator, well, before that, this ratio is a proper ratio. It's not improper. the degree of the polynomial on top is 0, the degree of the polynomial on the denominator is 2, so we're good to go. And we can factor this. So if we factor this denominator, what do we get? So this is going to be x minus 2 times x minus 3, right? So now that we've factored it, and we can't factor any further, this is a linear term, that's a linear term. And by that I mean, this looks like 1 times x plus -2 right there. So that's a linear term. And then this right here, this is 1 times x plus -3. Okay, so it has that form. And this term here, these linear terms have a power of 1. They appear only one time. Okay? Which is like the simplest form that we'll see. So what we're going to do now is we're going to use a technique to split this fraction into a ratio, a sum of ratios. Okay, so in order to do that, just go ahead and write out your rational function. And now we're going to introduce some variables. So it seems to be standard notation just to use capital letters starting at A. Okay, so like that. Now, the thing that's kind of strange is that if, for example, there would be a power of 2 here, we would write one more term involving the x minus 2. We'll see that in the next example, but for now, the powers of each of these linear terms is 1. So, okay, so now we need to solve for a and b. If we multiply both sides by this number here, or this product here, x minus 2 times x minus 3, multiply both sides of that equation, we'll have a 1 on the left-hand side. And then here, the x minus 2 will divide out that x minus 2, and we'll be left with a times x minus 3. And then here, the x minus 3 will divide out that when we multiply both sides, and we'll be left with x minus 2. And our goal is to find out what the variables a and b are. Again, if I didn't mention that earlier. So now we can just pick convenient x's to make this happen. So for example, if I pick x equals to 3, then what do we get? 1 is equal to, so that goes to 0. 3 minus 2 just leaves me with 1. So that means that b is equal to 1. And then if I pick x to be 2, then we'll have 1 is equal to a, negative a, actually. And that's 0, so that means that negative 1 is equal to a. Okay, so we found these variables. And we know that we can put a right there, and b right there. So now if I look at this integral, I can rewrite it as a sum. So so minus 1 over, where is it, x minus 2 plus, what is b, 1? So x minus 3 all dx. And because this sum, actually we can verify this real fast just so you can believe me. So this is going to be equal to minus 1 over x minus 2 plus 1 over x minus 3. How can we verify that? Well, we have minus x minus 2 times x minus 3 over x minus 3 plus, I'm running out of room, but multiply this by x minus 2 over x minus 2. And you get, and then all together, you'll have negative x plus 3 plus x minus 2 all over x minus 3 over x minus 2, x minus 3 times x minus 2. Combine those and you do get that back. So when dealing with rational functions where you have only powers of 1 linear factors, it's really simple to do this. You're just going to have a bunch of variables corresponding to each of those linear factors. But why would you do that? Well, we went from this, which we don't have any technique to integrate quickly, to so minus this integral here, plus this integral here. And now we can just do u substitution, right? Let u be x minus 2, du is just 1 dx. So then this would be 1 over u, natural log of absolute value of u. We've done that type of integration quite a bit. This would be minus natural log absolute value of u, which is x minus 2, plus natural log absolute value of x minus 3. And then don't forget your integration constant. So this integral went from something that would not be so straightforward to integrate to something that was really simple to integrate. There was just an intermediate step that you needed to take care of, and that was to decompose the rational function into a sum of rational pieces by using this method of partial fractions. Now, I do think we should take a moment to look at the table for a second now. So what do we do? We look at the denominator and we factor it into as many of the linear factors and quadratic factors as we can. So we factor it and we have just linear factors, no quadratic factors. But then notice here that for the linear factors, this m right here was equal to 1. This one only appeared one time, this one only appeared one time. So then, what did we do? We set this equal to, there's no quadratic, so we ignore that, a variable over the linear factor, all the way up to m. Well, m only went to 1, so we do variable over linear factor, stop. If it went to 2, we would go all the way up to variable over that linear factor with power 2. But since there is none, we don't need to. We do the same thing for b. And then we solve for the missing variables and we get our missing pieces, or the easier pieces to deal with. So that's partial fraction decomposition. The best way to illustrate it, though, is just to do a bunch of examples, I feel like. So let me do some more. Say maybe this one. So I think that's it. Yeah, this is it. So this one might be kind of long too. So 5x squared plus 3x plus 6 all over x cubed plus 2x squared plus x dx. All right, so we see that this is a proper fraction, a proper ratio, right? The degree of the denominator is greater than the degree of the numerator. So what we're going to do is we're going to factor the denominator into as many pieces as we can. So, and probably need to start up here. It's a very long problem, I think. So immediately I see that there is a common factor of x. So I'm going to take that out. X plus 1. And this factors to x plus 1 times x plus 1. But whenever you do that, go ahead and combine them. And you'll see why in a moment. Okay, so notice that x on its own is a linear factor. This is like 1 times x plus 0. That is a linear factor. It has that form. Coefficient times x plus number. So now notice that this factor appears twice, right? So in the table that you'll see that m is a 2, which means we're going to have two different ratios for this given linear factor. So what do I mean by that? I mean that 5x squared plus 20x plus 6 over x cubed plus 2x squared plus x. So there's only one factor for this linear factor. So we're just going to use a over x for that. Okay. But now for this linear factor, there's two of them. So I need two variables for that. One for x plus 1, and then another variable for x plus 1 all squared. So this is what you do. If the power was 3, I would make another one for x plus 1. If it had power 3, it'd be like a d over x plus 1 to the power 3. And you just go up until you hit that power. For each of them, if it was x squared right there, there'd be a over x plus a over x plus another variable over x squared. Okay. So now we need to figure out what A, B, and C are. So let's clear out all the ratios by multiplying by this, which we know factors to this. So we multiply both sides of this equation by this right here. I know that that's dividing out, so we'll be left with just the numerator. And then if I multiply a over x by this, I'm left with x plus 1 times x plus 1. So for this, I'll have a times x plus 1 squared. If I multiply b over x plus 1 times this, one of the x plus 1s will divide out, and I'll be left with x times x plus 1. And then if I multiply this piece by that, both x plus 1s will divide out with that, and I'll just be left with x. So now, as before, we just need to pick appropriate values for x so that we can figure out what our variables a, b, and c are. I think the easiest one would be x equals to minus 1, because then that'll be 0, and we're left with c. So what happens when x is minus 1? So then this will be 5 minus 20 plus 6 on the left-hand side. That's 0, and this will be minus c. So what is this? Minus 15 plus 6, so minus 9 is equal to minus c. So that means that C is equal to 9. Okay. So C right here, that's equal to 9. I know that now. Okay. So what about A and B? Well, to find out A, I can set x equal to 0, and that goes away and that goes away. So A is the next easiest one to find. So if x is equal to 0, then left-hand side, we just have 6. And then on the right-hand side, we have 0 plus 1 squared. So it's just A. And then that's 0 and that's 0. So right, A is equal to 6. Okay. And then to find B, it's pretty simple. We can just like put a 9 there, put a 6 there, and then pick any x, and then we'll find our B. What would be the easiest one? Or I could just put it on that equation there. So I guess 1 or something. Yeah, 1. So if x is equal to 1, then we have 5 plus 20, so 25 plus 6 is 31 is equal to A is 6, and this would be 1 plus 1 is 2, squared is 4. 4 times 6 is 24, plus B times 2, so 2B. So the 1 plus 1 right there. Plus, let's see, so plus 9. So what does that mean that, so if I subtract 24 on both sides, I get 7 is equal to 2B plus 9, which means that negative 2 is equal to 2B, which means that B is negative 1. Okay. So now this integral over here is equal to, so 6 over x plus, or minus the b, 1 over x plus 1 plus 9 over x plus 1 all squared dx. So these are all u substitutions now, all natural logs, because we have x plus, so this is easy, this is easy, this is easy. Well, this one takes a little bit more thought, but I know what that's going to be. It's going to be 6 times the natural log absolute value of x minus natural log absolute value of x plus 1. And then I'll just write the integral out so I don't do anything dumb. So 9 times the integral of 1 over x plus 1 all squared dx, just to be safe. And if I let u be x plus 1, so it's like, oh, it's just 1 over u squared. What am I doing? So 1 over u squared, so it's like the integral of u like that. So add 1, so just like that. So yeah, add 1 and then divide. So this is actually just going to be 6 times natural log absolute value of x minus natural log absolute value of x plus 1 minus 9 over x plus 1, and then plus c. I think that's the correct answer. I didn't rush anything too much. Yeah. Yeah. They combined it, but that's the answer. Okay. So so that was when we had multiple linear factors, or like linear factors with degree higher than 1. You have to make use of that. You have to, for each of those 1 through the degree, you have to make a new variable. So the degree for x plus 1 was 2, so there's a variable there and a variable there, and the denominator's degree increases as you get higher. Okay. So let's see, it is 206. Okay, so now let's do one where we have maybe quadratic factors. So you can see how to put in the variables for those now. What is the example they use? The integral from 2x cubed minus 4x minus 8 all over x squared minus x times x squared plus 4. Yes. Okay, so one thing to just immediately make sure of is that, the power in the denominator is greater than the power in the numerator, so this is a proper rational sort of expression. So let's go ahead and factor the bottom until there's no more factors. So we factor the denominator becomes x times x minus 1 all times x squared plus 4. Okay, so those are the 3 factors. They all have power 1, luckily. That's kind of my favorite case when they all have the power 1, because then we don't have to keep on writing out and having more and more variables. So then if we write out the whole expression, we're going to have a variable for that factor, a variable for that factor, that linear factor, and then we're going to have 2 variables for the quadratic factor. So this would be c times x plus d. And we got to now figure out a, b, c, and d. Okay, so to do that, I'm going to multiply both sides by the denominator here. We know that denominator looks like that, so all the ratios are going to disappear. So when we do that, we get the following equation. So x divides out, so you have a times x minus 1 times x squared plus 4. for this piece here, the x minus 1 divides out, so I'll have b times x minus 1. And then for this piece, the x squared plus 4 divides out, and I'm left with that. So dx plus d times x minus 1. And x minus 1 over here. X times x minus 1, because that's left over when that gets divided up. Okay, so what's the easiest variable to get a hold of? I'd say a. We take x to be 0, that goes away, all that goes away. So if x is equal to 0, then we have negative 8 is equal to negative times, so negative 4 times a, so negative 4a, which means that a is equal to 2. Right? That'll be 4 zeros, so 4 negative 1 times that. Yeah, everything works out. Okay, so we know that a is 2. Okay, what's the next one? Yeah, all those x minus, wait a minute. There was a mistake here. The x minus 1 divided out. This should be x squared plus 4. Right? That times this, the x minus 1's divide out, so you're left with that and that. So the x squared plus 4. But it still doesn't change my value for a because that was just 0, would have made it all 0 anyhow. Okay, so now what? Well, if x is equal to 1, then that goes to 0, that goes to 0, and we're left with b. So let's try that one. So if x is equal to positive 1, we get that 2 minus 4, okay, so 2 minus 4 is that negative? So, yeah, 2 minus 4, so I'm just going to write it out to be safe. Minus 8. That's 0, we're left with this, and this is just 5b. So this becomes a negative 2 minus 8, so negative 10. So then that means that b is equal to minus 2. Because this side would be negative 10, and then, yeah, so that means that b is minus 2. Okay. All right, so now we're almost there. We just need to find out what c and d are. Well, we can do this by solving a system of equations. There are 2 unknowns, okay? So we can make 2 different equations by picking 2 different values for x and then solving. Because we know a and we know b, we just need to know c and d. So let's just say if x is equal to, what's the most convenient one? It might be 2. Because if it's 2, then that's going to be a 1. I think 2 might be the best one. I don't know. We'll try it. Okay, so this will be, there's a bunch of 2's on this side. So 2 times 8, okay, 16, minus 8. Okay, so back down to 8. Minus 8 again, 0. Is that correct? Is there really a 0 on that tab? So it's 2 times 2 cubed is 8, minus 4 times 2, which is 8, minus 8, yeah, there's 2 8s and 2, yeah, so, okay. And then here, we have 1 there, and then 2 squared is 4 plus 4 is 8, and then a is 2, so 2 times 8 is 16. And then b is -2, so -2 times +2 is -4 here. And -2 squared is 4, so 4 plus 4 is 8. -4 times, so -4 times +8 is -32. And then we have 2c plus d. I'll see that. Times 2 times 1, so it's just 2 times that stuff. Okay, so now this is going to be -16, right? Because 16 is half of 32. -16, and we can move that over and make it +16. And then 2 times 2c is 4c. 2 times d. Oh, why would I do that? I can just divide by 2 on both sides. So move the 16 over and then divide by 2. And you get, well, I'll just write it out. And divide by 2 and you get that 8 is equal to 2c plus d. All right, so that gave us one equation, and now we just need another one. So what's another easy one? Maybe -1, maybe? So this is like, we're going to keep this for later. So now let's maybe take x equals to -1. So this would be on the left-hand side, 2 times, so it's a -2 plus 4 minus 8 is equal to, it's -2, so -2 minus 1, so that's going to be a -3 times 2 is a -6. 8 is 2, so -6 times, so -1 squared, 1, so -6 times +5, that's going to be -30 here, plus b is -2 times a -1, so +2 times 5, so plus 10, plus minus times a -2, right? Minus times a -2, right? It would be a +2 times -c plus d. Okay. So now we just gotta rearrange things. So -2 plus 4 is a +2 minus 7. I mean -8, so +2, so 6, 7, 8. So like -6 on that side. -30 plus 10 is a -20. Plus 2 times -c plus d. And then if I add 20 to both sides, I get 14 is equal to 2 times -c plus d, which means that 7 is equal to minus C plus D. Okay. So now that we have these two equations here, we can just look at them. So I'm going to subtract this entire equation from this one. This is how you solve systems. So 8 minus 7 is 1. 2 minus and minus C. So 2C minus and minus C is 3C. And then D minus D goes away. So that means that C has to equal 1/3. Okay. And once you have that, you can figure out what D is by just plugging it back into one of these equations. So C is equal, 7 is equal to minus 1/3 plus D. So that means that D is equal to 7 plus 1/3. So 7 plus 1/3 is equal to D, whatever that is. So 22/3. And unless I made a mistake somewhere in my arithmetic, I think that's good. It looks like I did make a mistake somewhere in my arithmetic. Where is it? I know it's with one of those additions and subtractions because I don't have enough room to write everything out, which this is like a good example of why you guys should have like a lot of paper in front of you, because even I'll make mistakes when I can't write out everything. Let's see, where would it be? Let's see. 8. Wait a minute. So this one is correct, I'm pretty sure. Now this one is where the mistake is, somewhere. Let me redo it. Okay. And by the way, you would know that this was a mistake if you got to here and you look and you plug in. I was very suspicious when I got that ratio, because when I plugged in a 2 there and a -2 there and a 1/3 there in my head, when I got down here, I started to look at that and I realized that that ratio was going to go to the denominator somewhere, and when you tried to combine them, it'd be a factor of 3 somewhere up here. So when I plugged in those numbers, I immediately was like, okay, something's off. So let's try x equals to -1 again, and see if we can write this out cleaner. All right. Just take x to be -1. All right, so now I'm going to pretend like I'm writing it on paper. I'm going to try to squeeze it all in here. So oh, that's where the mistake was. I just immediately, for some reason, I plugged in. Did I plug in a 2 here or something? I don't know. Well, we'll see. Yeah. So this one now for B. So B was -2. That is -1. -1 squared plus 4 is going to be 5. So I can just save room by doing the 5s. I trust that that's a 5 for sure. A positive 5. There's a 5 right there, and then b is minus 2 times minus 1 times 5 plus minus c, the x right there, plus d, and then minus 1, and then minus 1, minus 1. Okay. The only thing that I skipped was here, but I know minus 1 squared plus 4 is 5. So I just wrote that there. And I skipped writing negative x in parentheses times c, but that's fine. Okay, so this becomes minus 2. That becomes plus 4 minus 8 is, whoa, there might be an easier way out of here. There is. I can make things simpler. What's minus 1 minus 1? Hopefully y'all can see that. It says minus 1 minus 1. I can write that as the minus 1 over here. I can write that as minus 2. And look at that. There are factors of 2 everywhere, just to make my life easier. 2, 2, 2, there's 2's everywhere. So I'm going to divide by 2 on both sides of the equation to get rid of all those 2's. I'm just trying to be efficient with my space here. So that divided by 2 is minus 2. 8 divided by 2 is 4. That 2 goes away. That minus that is a 2 as well. So it's going to be just minus 2 times 5. That 2 was divided out, but now it's the negative stays the same. So the negative, it'll be like a negative 1. There's negative 1. 5. And I divided that 2 out. That minus sign goes in. So this will be plus c minus d. I just divided out this equation. I divided all those 2's out. Negative 1 cubed is negative 1. Negative 2 times negative 1 is positive 2. There's still the minus 4 there. Negative 2 times 5 is negative 10. Negative times negative is a positive. Times 5, so plus 5. That's another thing that's annoying about trying to squeeze everything in. Sometimes I miss negative signs. And then I have my plus c minus d. So on the left-hand side, we have minus 1 and 2 is minus 1. Minus 4, so it's minus, minus 1 plus 2 is a positive 1. And the minus 4, this would be minus 3 on the left-hand side. And then here we're going to have minus 10 plus 5, so it's a minus 5. And then we have c minus d. So if we add 5 to both sides of this equation, we get that 2 is equal to c minus d. That's better. That's for sure better. So this is, I probably missed the negative sign somewhere because I was moving quickly and squeezing things in. Okay, so now that we have these two equations here, what we can do is solve that system. So let me write down what I have so far. I know A is equal to 2, b is equal to -2. And I'm trying to solve for c and d. And I have two separate equations, two unknowns. We can solve this. And how do we do that? Well, if a is equal to 2c plus d, and 2 is equal to c minus d. So I can just add these together now. 8 plus 2 is 10. And then we have 3c. Is that correct? Wait a minute. Yes, I knew it there. I know that negative right there, I missed it when I came down here. I replaced them right here. So this is really, these signs have to be flipped. It's minus c plus d. Again, I was about to get a ratio. And any ratio is going to throw me off when looking at these factors. There's only even factors over there. So I was about to get some weird 10/3 business that couldn't have been correct. So here, we have like that. So now I want to get rid of the d's first. I'm going to subtract off this entire equation. By the way, in your notes, make sure to fix that. So this would be 6 c done. 2c minus c, 6c. All right, so that's one of the variables. So then I can just plug in and say 2 is equal to -6 plus d. Plug in for c there. And then we get that 6, 7, 8. 8 is equal to d. Okay. All right, so let's now do the integration, which is annoying, but we'll get there. God, just making mistakes all over the place here. Minus a minus. So it becomes 6 is equal to 3c, which means that c is equal to 2. That used to happen a lot. And that's why you put parentheses around here, because that negative is going there and there, so it becomes positive. So now that you know the c is equal to 2, 2 is equal to let's see. I need to check that. No, I don't know what, yeah, I'm right. So 2c, so this is 4, 8 minus 4 is equal to d. So d is equal to 4. Just plug in there, 4, 8 minus 4, that's d. All right. So now we have all of our guys. And now we can integrate finally. So this integral becomes, I'm going to write it all at once to save space. 2 over x dx plus, actually I'm going to take out the constants. So it'll be like a 2, and then b is what? Minus 2, so this will be a minus 2 integral of 1 over x minus 1 dx plus cx plus d. So plus 2x plus 4 all over x squared plus 4 dx. And this actually works out fun because now this is going to be 2 natural log absolute value of x minus 2 natural log absolute value of x minus 1. And then notice here that we should actually expand this more. So this would become hopefully you can see this. Actually, I'll leave the 2 in there because it works out fine. X plus 4 times the integral of 1 over x squared plus 4 dx. Hopefully y'all can read that. Now look here. If this is your u, then du is going to be equal to 2x dx, right? Like if I let u equal to x squared plus 4, 2x dx is du. So this is du over u, same thing with the natural logs. So 2 natural log absolute value of x minus 2 natural log absolute value of x minus 1 plus natural log absolute value of x squared plus 4 plus 4 times this integral. But look what type of form that has, 1 over x squared plus 4. How can we do that? Well, it's a sum of squares, right? So to finally, we need to figure out what that integral is. And we can do that using trig substitution maybe. So this is going to be or do we even need that? Let's see. It's just, I think that's just arctan. Where's the, you look at your tables of derivatives. That is arctan, I'm pretty sure. Yeah, it's arctan. It's one of the tables. So your a here is 2, and your u is just x. So this is going to be 4 times 1 over 2 arctan u over 2. So x over 2. It better be in, yeah, and then there's plus c, of course. So I was about to just do this from scratch, but we have a table for things that look like that. And that's just something you need to get used to, that when you see 1 over the sum of squares, immediately think of trig. It's a sum of squares. And one of the trig functions is most likely going to solve it. Okay, so there are a few hiccups on the arithmetic over here, but we found a solution. And this is when dealing with quadratic factors in the denominator of your rational function. Okay, so it's quite a bit, I know, but you'll only have one question on this on the exam, and I'll probably post a solution to one of the similar ones from the textbook at some point before the end of the day, Friday. So that'll be it.